later. The member of good evening wherever you are. It's my pleasure to introduce Dr. Gaziano, our speaker for today's webinar. Dr. Gaziano is a preventive cardiologist and the international recognized chronic disease epidemiologist. His research interests include the epidemiology of chronic disease using large data sources. He has a particular interest in the lifestyle, metabolic, biochemical, and the genetic determinants of common chronic disease such as cardiovascular disease and cancer. A centerpiece of his research involves the conduct of observational studies and clinical trials that are embedded in a healthcare system and the curation of electronic health data from many sources. Dr. Gaziano serves the director of the CSP Epidemiology Center at Massachusetts Veterans Epidemiology Research and the Information Center, and as one of two principal investigators for the Meaning Veteran Program, which is a project that will enroll 1 million veterans into longitudinal cohort with stored biospecimens, self-reported data, and the rich electronic, clinical, and administrative data available in the VA. He is involved in a new initiative in health data science that combines the health data of the VA, including data on about 24 million users of veterans' healthcare system over the last 2 decades, with the computing power and the expertise in the Department of Energy. Dr. Gaziano is a principal investigator of the Physicians' Health Study, which is a large-scale trial-based cohort of over 29,000 physicians followed for over 35 years. He has also served as PI, co-PI, or co-investigator on numerous of other cohort studies and large-scale trials. He serves on the advisory committee for UKBiobank. Dr. Gaziano oversees several fellowship programs and teaches advanced epidemiology at the Harvard School of Public Health. He has published over 700 journal articles, reviews, book chapters, and books. He served as an associate editor for the Journal of American Medical Association. He's a fellow of Royal College of Physicians. Today, Dr. Gaziano will share their experience on collection of biospecimens in the Meaning Veteran Program. We are pleased to have Dr. Gaziano to present at today's webinar. Dr. Gaziano, the floor is yours.
Thank you, Rungling. And I'm going to go about, just to keep us on time, go about 35 minutes or so, saving about 10 minutes at the end for questions. And, you know, I won't be watching the chat, so probably, but it's not a massive group. If there was, I may pause at a certain point to see if there's any questions, but I think, you know, people can speak up given the size of the group here. So I'm going to just start off with the innovation in home collection has to be built into the existing infrastructure, and all of our lab processes were set up to use venipuncture bloods. So I'm going to talk a little bit about the MVP logistics at the beginning, and then how we collected and processed the specimens, and then how we use them, because that also drives what you collect and how you collect them, what you can do with what you collect. We introduced MVP Online, which really changed a lot of our logistics, and then COVID came in, and it had some impact on specimen collection. And the focus of the novel things will be on saliva, capillary blood, and in-home standard phlebotomy as the technologies that we're pursuing in MVP to expand our capabilities. So just as a reminder, MVP is built on a massive, the largest integrated healthcare network in the United States with 1,700 points of care. While there's 152 medical centers, they all have there's almost 1,000 outpatient clinics. Now those are places where phlebotomy can happen. Now we're right now restricted to that phlebotomy happening only where there's an IRB approved site, and I'll explain why in a moment, but this does provide us with some places beyond the sites where we could get phlebotomy from. Now, the backbone of the project is really the informatics infrastructure and the corporate data warehouse, where all of the data from the EHRs, except the actual data from images, comes all the way into the corporate data warehouse in real time. And this data goes back about 20 years. It's one of the most granular EHR databases in the world, which is why we're mining it with the help of the Department of Energy to good effect. And as an example, we have 8 billion lab results and 3 billion clinical notes. Well, that's the backbone. Now, the blood collection is one of the 4 central tenets. So the 4 legs of the stool are to be able to add health and lifestyle information that's not in the EHR through questionnaires. We have a biospecimen that we collect for our own purposes. The research acquired, and I'll talk a little bit more about that, but it's a non-CLIA research collection process. And then our assays at this point are also in non-CLIA certified laboratories. Then we have access to the medical record. We have access to the patient, so we can recontact them. So I want to put the blood collection in that context. We set the original structure was to send out an invitational mailing. They would send back a baseline 15-minute baseline survey with some health and lifestyle indicating they were interested. We'd send them an appointment mailing, and they would come in for a study visit where they would do in person informed consent and HIPAA. That was 10 years ago. We're celebrating our 10th anniversary now. 10 years ago. That was the process that we were required to do to explain the consent process for a genetic study in the VA. And that's where the blood collection happens. Because the consent was face-to-face, we had that opportunity to collect the blood. And there are 2 ways that the bloods were collected. They were either by the research staff, or the person would be sent to the laboratory with a tube provided by the research lab and bring it back. And then we sent them a thank you mailing with a lifestyle survey. Now, we started off with we run about mid-60 sites. We've been in about 80 sites altogether, with more sites coming on this year. But you can see the yellow stars are the satellites where the site staff will go out to meet the patients where they're coming in. And the patients are coming in, they're being mailed to and coming in accordance, if we can help it, with their appointments. And that allows convenience for them. We don't provide them with travel vouchers. We don't provide them with compensation. They're willing to do this. We got our motto from the veterans, which is another way to serve, but they're willing to come in and give this biospecimen to us in real time. Now, we had hoped to be at 1 million, and we were on pace to do that, and then the pandemic hit, but we're at about 850,000 at these sites, and we have mailed to 6 million veterans 16 million pieces of mail. And all the mailings are centered on these sites, which is where the specimens are collected. Now, what happens is it's very simple, bare bones. It's a 110 ml EDTA vacuum tube, which is a purple top. It's shipped on a wet ice on a freezer gel pack. We've created kits that can be sent for an individual single tube or for a dozen or so tubes. And you can actually put a couple of these cassettes in a larger gel pack. The gel packs are frozen the day before. There's no processing in the field. They're just kept cold, either in a refrigerator or on wet ice, until they're shipped overnight express mail. And they arrive in Boston. About 95% of them arrive the next day. Now, we note certain things about the person, when was their last meal, and we note certain things about the specimens when they arrive in the lab. What's the time the collection was taken is logged, and the temperature of if the freezer gel packs are still frozen or not. So we have all that information, metadata about the specimen. Now, here's our wonderful lab staff. Started off with a totally manual process. These kits come into the laboratory. They're opened and processed. Then they're sent into the centrifuge. These centrifuge tubes are then putting into our TCAN separator, and they ultimately end up in our BioStore. Now, here's some of the machinery that we helped create. This is the TCAM processor. We now have 3 of these machines. It operates eight specimens at once. Once the specimen is spun, the cork is removed and spun, there's a reader for the barcode, and then over here there's a reader for the level of the separation between the plasma and the cell layers. And then that over here with that information being related to the micropipettes that will first drop down and remove plasma. We're now collecting all the plasma available up to 1 ml aliquots. Then we go in and get 2 1 ml aliquots of Buffycoat. The last thing that happens is that 15% of that 1 ml aliquot from one of the 2 Buffycoats is put into a special tube, and that comes over to our Beckman processors for DNA extraction. Now, the throughput on these extractors was doubled by adding a second agitator head by our design, because the smart head that does the action is idle while the specimens are being agitated as the various solvents are added. And now that product is actually provided by Beckman. They end up in this massive storage facility that can store 4 million aliquots with a robot that runs down the center of this 2-story high machine. It operates at -20. This is gas phase nitrogen operating at -20. These robots don't function, at the -80 because of the lubricants that can function at -20, but not at -80. When I went over to decode, they had an old Toyota robot that actually had a parka on it, had some insulation on it to keep it warm and keep the lubricants warm. Now, the reason I went through this is that we geared this whole system toward venipuncture specimens, 1 ml aliquots of plasma. Other structures, that's going to change. Also, the quantities of DNA, the amount of DNA that we extract. It's all dependent on what we're using the samples for. Now, this is a bare bones operation compared to, say, UKBiobank and all of us. We get 1 EDTA2, but given the fact that a lot of these specimens, a lot of these assays can be run on very small amounts, it's enough to keep us in business. In addition, we have information on the individuals, and we can go back and get more specimens, but everybody gets genotyped with an MVP array. It's the original Affymetrix, now Thermo Fisher MVP array, very similar to UKBiobank and what was developed by Neil Riesch out at Kaiser. And then we've added an ethnic specific array, but about 30% of our population are running through. And we've moved from exomes to whole genome sequences, of which we've done about 150,000. We've done 38,000 methylations, and then we're moving into metabolomics at scale and piloting proteomics. So we will be using the plasma, but again, it's microliter amounts, and the plasma is very precious. DNA we have very relative to the amount that we use is an abundance of DNA. So here's how we've processed samples. We've got of the 848,000. There's a little lag to getting the samples in the lab, a little lag in what's processed. We've had to double DNA extractions at times, so we've done more DNA extractions. But we've stored 3.4 million aliquots, and we've shipped out 1.1 million specimens for the genotyping, the focused array, the whole genome sequencing, and the methylation. Now, and this is our activity this year. We've completed our 150,000 specimens to our whole genome vendor, which is operating on the Illumina platform. We've got 2 vendors doing the genotyping for us, and the methylation is on hold because we're doing QC before we resume sending more. We're going to just check the quality of the data. But this year, during the pandemic, while we were not getting as many of the standard array samples in, we're batching them after periods of time because our recruitment is obviously down. We were sending the ones that were stored for the ethnic specific array. Now, here's one of the problems. One of the problems is this is our heat map of where people come from, and the red dots are the sites, and you can see everything is proximity of the sites, but we have people in Boston that come all the way from Maine. These are zip codes of residents, and we can look at the heat map for a particular center, and our catchment area is all the New England states, because people will come to VA Boston to get tertiary care within the New England basin. But it could be an 8-hour drive from northern Maine, or a 5-hour drive from mid Maine down to the center, and that's somewhat inconvenient. And there are holes in the recruitment process. So we developed an online portal that gives out-facing information to everybody. It's got a science portal that is coming online for our investigators, but I think probably most importantly, it's a recruitment tool and a recruitment engine. Now, the big advantages of the online strategy is that it expands enrollment nationally, and we can actually attract, retain, and provide feedback to veterans, our veteran partners, in a more agile way. It can accommodate our evolving needs. As you'll see, COVID was one of our evolving needs. And we can decrease the time between program activities and implementation, and improve data quality, as it doesn't go through a input process like the paper surveys do. However, our veterans, we know our population, will always need to do some paper activity for the current enrollees, because there is a proportion of them that don't operate online, and then we do a rapid response. Now, the recruitment strategy, one of the key factors was getting a credentialing sign-on, and veterans do know how to sign on to various things within the VA, but there are 4 different formats that they can use when they sign on. As they sign on to it's something that they know. We've got a database with all veterans in the database, and we have different sign-in strategies. But once they're authenticated, they can complete their consent process, which has questions about the consent process at the end. They can schedule an appointment visit, and then they can fill out all their questionnaires. And this was launched fortuitously in the fall of 19, and we used it during the pandemic, and we've enrolled 10,000. Now, our limitation in enrollment has been the biospecimen collection. So our enrollment strategy of steering people to enrollment is steering people that actually are in the catchment areas of the places they can get the EDTA collected. So there's always going to be a lag in getting the specimens, unlike the face-to-face recruitment strategy. So to have full potential, we need other ways to recruit. At the same time that this happened, COVID happened, and this is a timeline. I'm not going to go into much detail of our chronology in MVP. We shut our sites down. We were the first large activity to phase out recruitment at sites, and then we, as you can see, we launched a bunch of science, and some of that science was dictated by getting biospecimens from participants to look at antibodies. And so we launched our pilots for home collection, and also for mobile phlebotomy. So these are our activities. We restructured the sites. They were doing a lot more phone. They were steering people to online. We've served as a registry for the vaccine trials. And then we did a COVID survey, and we have the capacity to survey for the kinds of attitudes about blood collection, and I'll share that data with you. We also expanded our phenotypic work on COVID, and then we launched Cypher, which I will digress for a moment and tell you a little bit about, and then the specimen collection. And then, as I said, we organized a number of COVID science studies, as did many large databases. I think that COVID showed the value of the very large cohorts that have a capacity to get new information as rapid response entities. While they're a select segment of the population, they are in place and ready for access. But one thing we realized is that our specimen collection, being site-based only, decreased our agility to actually rapidly respond in a biochemical way. So as I mentioned, we did send out a survey. We got 250,000 responses. That data is being placed on this Cypher. And this online platform was put to good use, and we can now use that for quick and dirty surveys. If we want to do something quick, we would do it by phone, and it's a smaller number, of course. We have a call center in Canandaigua. And then in the future, we've got a mental health project that we're doing to recruit mental health subgroups that will be using online, but we've got vaccine work that's going to be doing with a vaccine survey. And then we will be doing, as I'll mention, some blood work looking at antibody decay among vaccinated individuals, and potentially in those with who are COVID positive. Now, we took all this information from the questionnaires and we put it on our newly launched phenomics library called Cypher, and I'm only going to digress just a second. Cypher is our centralized phenomics library. It's inward facing now, VA investigator only, but it soon will become available to anybody, and it has all of our curated phenotypes, lab data, definitions, but we used it to put the phenotypic data. We launched it about 15 months in advance, made it available to all VA investigators, not just MVP investigators, because we had this need to share the centralized COVID data. And you can see in the VA, we have about 1.5 million people that were tested as of April of 21 anyway, and 250,000 of them are positive, and about, it's about a 20% positive rate in the testing that's done in the VA. And we developed a severity index, and all that data is available on this online platform. But then what the next piece was being able to get bloods. So in MVP, we have now close to, this is June data, we have close to 40,000 individuals who are COVID positive, and we've been doing some genetic studies looking at some of the outcomes based on germline genetics. But this is an opportunity for us to look at long haul COVID, and to look now, the vaccination rates are quite good in the VA, and so it's also a capacity to look at vaccination. So here was our strategy to look at other collection modalities, and we had started in the fall of 19 with saliva, knowing that we needed a support for online. And then through some research in the COVID space, we happened upon a couple of different devices. Now, the Neoterix Mitra is a blood spot, and that's a technology that's been around forever and ever and ever. So I'm not going to focus a lot about that, but these capillary devices are relatively new technology, and I'll describe in much more detail about that. We also have a mobile phlebotomy contract, so we can go out and get biospecimens, but as I'll share with you, the response is much lower when especially, at least perhaps during COVID, when we were asking, would you mind if someone came to your house? We got response rates that were much lower. Now, Tasso has got a new improved version, and that's what I'm going to really spend some time talking about. But let's talk about the saliva. It's the Origin Saliva Kit, and it requires following very careful instructions. First, we went out with the Origin instructions as the primary mode of instructing our veteran partners how to give us a biospecimen. Then we realized we had to do some translation. In the VA, we try to target a 5 to 7 grade reading acuity level in all of our literature, and the Origin instructions are a little higher than that, and we realized that there perhaps was some confusion about the kit, and that's led to one of the challenges that I'll describe. So we completed over 3 months at 3 different sites, 300 kits, and I'll give you the results in a minute, but we also got feedback on acceptability. So the process went as follows. We chose 3 sites, and we collected a blood specimen, and then we offered them an opportunity to be included in the saliva pilot. If they consented, they were given a packet to take home and sent back to us. So the reason we did that was because we wanted a fresh venipuncture sample to compare to the DNA that we get from the saliva. And then we got the reminder calls to the partner. They provided a sample as instructed, and then they mailed the sample to the biorepository. And biorepository received samples, processed them, and then we took the paired DNA and we compared it to the results that we get for genotyping. And this summarizes those results. We had 3 centers: Manhattan, Palo Alto, Portland, and we recruited 100 at each. We got about 54% of the people to agree, and then we sent kits to the 300. That's of the people that were approached, and then 72% sent back a sample. Most of it was front loaded, but the reminders did help get some of the stragglers to send the samples in, but we got about 3/4 of the samples back. Now here's the basic results of the saliva processing that we had to adapt all of our strategies because we're now working with saliva instead of buffy coat. And DNA quality at the outset was good in fewer of the people than it was bad at the outset, but then we realized after checking concentrations, we did a cleanup. We were able to get good specimens in about 64% of the population. The main problem with the bad specimens was that there wasn't enough saliva volume in the tubes, and for any number of reasons, people could be dehydrated. They might be taking medications that dry up their saliva, but there just wasn't enough volume. But about 2/3 of us get 2/3 of the time we got sufficient for DNA, and the quality of the DNA once cleaned up, it performs this very similarly to the biospecimens connect the DNA extracted from buffy coat on these same individuals. So we thought, well, that saliva is a possible strategy. It could be done at home. It could be done through the mail, but it doesn't afford us the ability to get any plasma. And for these COVID projects, that was essential. We need plasma. So we moved into comparing the TASO SSP that's available last year and the standard micro blood spot. The blood spot's fairly straightforward. You prick yourself and you collect a blood spot, and it's sent to the processing laboratory and then processed as a blood spot. Very old technology. TASO is a kit that has a device, like a lancet embedded in the device. You clean off the arm, you stick it to the arm, you push a button, and a lancet goes in and retracts. And then you wait a few minutes doing something else, and you let this little tube fill. Then you put the tube in disconnect the tube, put the tube in a mailer, and then it's in the laboratory. Now we sent these directly to a laboratory in Palo Alto, Mark Haladny's laboratory, where he was extracting the serum, and then from the serum doing antibody tests. So during the pandemic, what we were really interested in is seroprevalence, and then later, durability of antibodies. And so we needed in-home collection because people were not coming to the sites. So we compared the two types of mailing to mobile phlebotomy, which I'll mention only briefly because the quality of the tubes are the same. And then we're actually moving on to TASO Plus. And there were a number of COVID-related goals. I'm just going to move fairly quickly through the different experiments. So we enrolled 312 people with and that was a result of a 52% consent rate after we contacted people. 90% of the participants sent back devices, and then we went mobile phlebotomy. And I'll show you that it was a much lower response rate in a moment. And now we're moving on to the device that collects more plasma, which I'll describe in a moment. So with the at-home capillary part of it, they were verbally consented over the phone, and we sent out 2 different types of devices. And then we assessed 4 assays on both types of specimens for antibody levels. For mobile phlebotomy, they were verbally consented. We did all the consenting, and our vendor, which is a Quest subsidiary, is collecting 3 venous blood specimens over the course of 12 months, pre-vaccine and then both of the other 2 post-vaccine. And we're assessing seroprevalence over 12 months, but it also gives us the information we need about the quality of the specimens. So, and this data is making its way through a manuscript. I'm going to share some tables of that. So, consented people that we invited was 52%. We received a specimen about the same from the blood spot and the TASO, but the viable specimen was a little lower in the TASO, but about 85%. We're doing a little better now, and I'll explain why that is. And these are older individuals. There's one thing I wanted to point out, these are that we oversampled people that were vaccinated for the purposes of the science that we were doing. So here's the here's the feedback on the devices. How was your experience? How easy was the collection kit? How easy was the specimen device? How easy was the mail return? So on and so forth. And on a 5-point scale, most people found the experience favorable, and there wasn't much difference between the two different devices. So that was reassuring to us, whether they have to prick themselves or they let the machine prick themselves. So there is a widespread acceptance. Now here is the results. The results for the antibody assays from the serum collected are comparable, perhaps a little higher sensitivity and specificities for the serum that came from the tasso than from the blood spots. But we thought that both of them were, acceptable ways to get serum, and now they're moving on with the tasso plus to doing EDTA. Now I will mention with the mobile phlebotomy, by comparison, remember 52% response rate, we only got an 8% response rate, but this was two reasons. One was the vaccination status was required, but the other was that we think that people's willingness to have a person come into their house. Now maybe that was state dependent in the pandemic. We got specimen received 75% of the time once someone agreed to be in, compared to about 90% with the other at home. But the quality of the specimen was superb. It's a venous blood. We also got PAX tubes just as an experiment on going beyond the EDTA, obviously for RNA experiments. Now, the last thing I'm going to talk about is the Tasso Plus is a newer device that allows you to between 500 to 700 devices, but there have been a number of improvements. You open the pack and you remove all hair, and there is a warming pack that you put on to warm the area before you put the device on. You load the device with the tube, you remove this protective cover that prevents it from being activated accidentally, and then you carefully place it, stick it with the gum to the arm. You push the button, the tube fills. While you're doing something else, you remove the device, you remove the tube, you agitate the tube, and then it goes into a mailer and comes back to us. Now, the Tasso company will provide the kits. We're experimenting now with whether we want to send the kits out, and they will also process the samples. We also have one of the laboratories that does our genotyping is doing this experiment we're doing a comparison of the processing of the specimens, and we get very good DNA yield from both companies. I don't think it's a meaningful difference, and enough to an excess to do the array, the GWAS array, the methylation, and the whole genome sequencing that we're processing with some to spare. The amount of blood in the tubes is one of the most variable things from the Tasso SST, and that some of these changes in this process are meant to decrease the variability in the yield of the biospecimen, but the potential yield is this. What we don't know is what the trade-off is. The instructions are more complicated, and so your yield might go up, but the ability of people to do it properly might go down the more steps there are. So there's always trade-offs. And so, to summarize, we're expanding to complete our COVID projects. We have new pilots to compare the venous blood draws with the Tasso Plus, just like we did the saliva. The difference is that the venous blood specimens are refrigerated, and right now the Tasso Plus are sent back ambient without a freezer pack. Now, a freezer pack could be put in, and in the physician's health study and women's health study, we send individual kits out. They're healthcare providers. They go get their blood drawn at their hospital, but they're the ones that put the freezer pack in the freezer the night before and send it to us, and most of the time they get it right. That would really complicate things. I think for many of the plasma processes, the buffered plasma is actually quite stable. Proteins are actually quite stable. Some metabolites are not. So we're trying to compare. We're going to do at-home collection moving forward with the Tasso Plus. We think that we're in the process of scaling up, and I think that's that's the game changer. So I'm going to end here by acknowledging all the staff in the field that have worked tirelessly through the pandemic and have cooperated with us to kind of move to online and to move to this kind of collection process. And then the veterans, of course, which are our most important partners in the process, but they're incredibly willing to, the toughest part is getting them on the phone if we're doing mobile consenting. But once they're on the phone, they're very willing to participate, and they're not participating, they're not busy, or they may be infirmed, or there might be some reason. But we have very good, once they're in the study, we have very good follow up. Now the question is, and a sentiment of volunteerism. The question is that we suspect that will translate to sign up online, and we're making now that as an option available with expansion through the fall, to be able to go online and recruit, and then they will be given an option through the online strategy to either come into a site if it's nearby, or to have us get mailed to them, and they'll be setting those preferences online. So we think it's a very viable, process for collecting a very valuable sample. You're going to have to be very, very careful about doling out the serum or plasma. We have to make a decision on what do we want, what preservative do we want in the specimen. If everything else is EDTA, we probably will stick with EDTA going forward, but we think that the in-home collection is going to be a game changer for us. So I'll end here with a picture from not far from my little big cottage, which is my happy place, and I'm happy to answer any questions in the remaining 10 minutes or so.
Thank you so much, Dr. Gaziano. It's a wonderful presentation with a lot of logistic details and the advanced technologies. Jeff, you have a question?
Yeah, thanks, Mike. Great to see this taking shape. Can you comment on whether there was any differences in the demographic distribution of receptivity of the various types of biospecimen collection modalities? We really want to have a very diverse cohort, and it may be that some of the technologies may not be acceptable to some of the participants.
Yeah, no, I think that's as always, Jeff, you're spot on. First of all, we see a slightly lower acceptance of the online strategy for our minority population. That's number one. And then the same thing holds true for the mailback strategies. But it's only a modest reduction in the acceptance of the strategy overall. There's not a big difference when you get someone on the phone. There's not a big difference in consenting by the various subgroups, but the follow through is a little bit lower in the underserved minorities, and we see the same thing when we send out questionnaires or recruitment strategies directing people to the online strategy. We tend to get a slightly higher proportion of white veterans than we do our underrepresented minorities.
Okay, Pablo, you have a question? Okay.
For the opportunity. Mike, great presentation, really informative. A lot of information, but I can see that you were very excited about it and it comes through. My question is on, I guess maybe a follow-up as well to Jeff's question. It's about consent and ethics of like the data/specimen collection, because you said something about you usually call the participants to not get their consent. So I want to know what type of consent are you sort of like getting? Is a telephone call recorded? Are the participants able to change their minds at any time? Like even though they took the blood or saliva and sent it to you, can they 5 days later say, "Hi, Mark, I decided I don't want to be part of the study anymore"? So what are the ethics and consent around your study? Because I'm also like thinking a lot about that, because in South Africa, they've just recently introduced POPI Act, which is like Protection of Personal Information Act, which is very like sort of like a big thing now, because everybody's like freaking out, both researchers, corporate and academics everywhere in South Africa, like freaking out as well. So I'm just interested in ethics and consent of the study. Thank you.
Yeah, well, you were breaking up a little bit, but I think I got to just the question around the ethics. consenting ethics and understanding. I would say that our experience, we worked very hard with opinion surveys well before we got started. And what's nice is that we don't see big differences in our racial and ethnic subgroups in recruitment compared to the general population. I think we have about 18 or 19% participants of African ancestry within the cohort, which is very similar to the source population that we're recruiting. But we went, to great lengths to sort of understand what people understand. For the consent process, for the recruitment in general, embedded in that is for the blood collection. We go to pretty great detail about what the biospecimens will be used for, how they will be protected, how the data will be protected. I think that is really, in our surveys, the main concern that our veterans have is that if we're generating all this data, and I think it's a real concern, we've had FBI briefings talking to us about how do we secure the genetic data, is data security. That's the main concern. And we've, I think, done a reasonable job of transmitting that. We've gone over and over and over again the processes by which someone does it in person to explain those risks and how the biospecimens will be stored, how the biospecimens will be accessed, utilized, and we've made it very clear that there is always the option of opting out in the future. We've had a relatively modest number of individuals, but there is a capacity to opt out. You can have an opt out is a multifaceted process. You can opt out for recontact, but let us continue to use your data. You can opt out of access to your data. You can opt out of allowing us to access your biospecimens and request your specimens to be destroyed. And we do those checks before we send anything out. And I would say that the general, our general sense is that there might be some differences in people's perceptions about going into the study. I mean, that may have something to do with why we get slightly different rates, but once people are in the study, there's a consistent feeling about their participation in the study from an ethical perspective. I hope that answered the question. As I said, you were breaking up a little bit.
Yeah, thank you so much. You did answer it correctly, Mike. Thank you.
Yeah, we have a question from the chat. Albert Tenesa, you want to speak up or you want to read the question to Michael?
I can speak up, I don't mind. So I was wondering how feasible. Well, Mike, thank you. It's an excellent talk. So I was wondering how participants need to wear the machine, the tasso.
It's about 5 minutes is the standard. If they heat up the arm, it's about 5 minutes. But I don't know. We're trying to collect some of these user feelings and about that, and we've been working very closely to develop the whole strategy with tasso. But I don't have a range of what that is, but it's generally about 5 minutes. But I'm sure that there's some variability.
Yeah, well, okay, yeah. I was wondering how feasible would be to do repeated measurements across the day, and whether that would become very uncomfortable.
Yeah, so it depends. I suppose it's a skin prick, and I suppose it depends on the frequency with which. So we've only been testing. We've been getting repeat measures in people who have had either recent or remote biospecimens. The remote could be years before. So we haven't done the tasso on a repeated basis. We are building in the mobile phlebotomy as a time zero, 6 months and 12 months. And the repeated measure aspect of it might be some of the reason why people are a little less inclined to do it than what turns out to be a one-time, tasso or blood spot.
Oh,
but I think it would be amenable.
Thank you.
I think it'd be amenable. It's just a matter of finding the balance between what people are are willing to do. You would get whenever you do something like this, you get a subset of the population. But I don't think it's a scary thing. It would be a good question to ask if the experience itself dissuaded people to do it again relatively recently before they've forgotten the pain.
Yeah, but yeah, but I was thinking more of you know, I think the technology is very good to maybe try to do experiments that no one has tried. So, for instance, measuring insulin levels before eating and after eating in a home environment, that kind of experiment, but that would become two samplings in very short time, maybe in 30 minutes or an hour, and then that may become very uncomfortable. But usually those type of studies are done in the clinic in not very
yeah. Well, I mean,
realistic environment.
The basic devices of sort of capillary processes or surface measurements. I mean, we all are aware of those diabetes devices which monitor glucose on the surface in real time. But I think that these devices are going to have a lot of capabilities for us. They're not without some cost, but the key thing is that an enormous amount of planning has to go into how to use them. The big thing is that we are having to retool entirely an operation that's based on venipuncture volumes and 1 ml aliquots. And now, and I didn't mention that we have a backup biobank in Albuquerque where we're splitting the one Buffy coat that hasn't been tapped goes there, and at least one plasma aliquot goes there too, and they're going to help, with some of the separation. But now you're getting smaller volumes, and how do you split your sample? These smaller volumes of DNA. How do you split your sample? How do you design your machinery for microliter volumes when you were working with milliliter volumes? It's an enormous amount of logistics goes into this kind of a switch that we're making. And what we don't want to do is, it's not, I think switch is the wrong word. We're not switching technology, we're adding a technology, because I still think we're going to do an awful lot of basic venipuncture processing, but we're adding the possibility of processing these capillary tube collections at much smaller volumes.
Jose, you have a question? You're on mute, Jose. Your hands on up, okay? Go ahead.
Sorry, I'm not Jose, I'm Jesus. Another biblical fellow. So I'm telling Dr. Gaziano, beautiful lecture. Thank you very much. I have the same question of Albert and Nessa, but I do have another one. Do you have problems sending the samples throughout all United States to your laboratories? I mean, if I understood well your lecture, you did not froze the samples. The samples arrived without processing, and I don't know, they should take more than 1 or 2 days if distances are on consideration. And I don't know, how are you dealing with that? Also, the plasma is usable still, and I've heard in the last part of your comments right now that you were changing your, of course, all your technology since the sample is little. You still can get Buffy coat from that sample?
Yeah. So what we've, this is really over decades. We've been sort of exploring, in some cases, pioneering ways of collecting biospecimens, along with colleagues at Oxford. We did an experiment with Linda Youngblood in Oxford about 3 decades ago, where we compared a plasma specimen collected and sent, kept cold and sent on these gel packs, with a sample that was sent at ambient temperature. And it turns out that surprisingly, quite a few of the protein measures and metabolites are pretty stable in buffered plasma. I think time is critical. Certain things we know are not very good when they're sent overnight and not processed in the field. Things that involve the white cells consuming things like glucose, or things that are unstable like vitamin E and vitamin C that need special tubes and light shielding and protection and early processing. RNA is an important one, and there are technologies now that are getting RNA from simple plasma. But that's why we're experimenting with the plasma. Now, one of the things I didn't go into much detail about is that we are in one of these TASO experiments. We are taking plasma selected and held cold from venipuncture with serum collected from the TASO device, and then we have to make a decision of whether we're going to go with serum or plasma. But we're comparing a metabolomic scan and a proteomic scan to see where the differences are. Now, the numbers are going to be small, especially since we're measuring thousands of metabolites, but we'll get some sense of when it's good. I think the key thing is that we're creating we think the DNA is going to be great, but we're creating a library, a capability to get specimens in a different way, but also a library. If it turns out your assay needs to be refrigerated, whatever it is you're measuring needs to be on refrigerated samples, then you could restrict your analysis to all of the 850,000 refrigerated plasmas in there. If, on the other hand, it seems to be good in both, then you'd be open to both. But all that metadata also has to be kept in the library. Again, volumes is another issue. If the volumes are too small, then you could restrict it to the ones where you have we have multiple mLs of plasma in contrast to just a few microliters. So I think that that's another piece of this, is that you have to build in the knowledge acquisition about what these assays are good for, and not just make an assumption, but always build in, if you're doing an assay, you're going to have to compare. If you've got a novel assay that you've done on field processed refrigerated plasma, and you want to try it on our non-field processed refrigerated plasma, or you want to try it out on these TASO devices sent in ambient, then you're going to have to do those natural experiments, and that's actually what we're building in. And I caution anybody to, before you scale anything up, that you build that capacity to explore within the biobanking culture.
Okay.
Thank you, Dr. Gaziano, again. Thank you very much.
For the interest of time, thanks again, Dr. Gaziano, for the excellent presentation and the discussing. And sorry for the technical problem at the beginning of this webinar. Our next webinar will be at the end of September. The IHCC Secretariat is preparing for this next webinar. They will send out the detailed information soon. So stay on tone. Okay, thank you so much. I think we should end of this webinar. Thank you for your participation.
Thank you all.
Bye.
Thank you.